In this video, we'll go through Azure Machine Learning in detail, including its capabilities, the Azure ecosystem that supports machine learning, and the various ways we train and build models, starting with what is Azure Machine Learning, followed by who is machine learning for. Then we will look into its infrastructure, readiness, and security. Then we will dive into machine learning project workflow. Following that, we will understand MLOps, DevOps for machine learning. And at last, we will explore the Azure Machine Learning Studio. After that, we will have a demo too. So without doing any further delay, let's start with the video. So what is Azure Machine Learning? Azure Machine Learning is a cloud solution that helps you speed up and manage your machine learning projects. It can be used by machine learning specialists, data scientists, and engineers in their daily workflows. Models are trained and deployed, and MLOps are managed. You can use an open source platform like PyTorch, TensorFlow, or scikit-learn to build a model, or use one created in Azure Machine Learning. Model monitoring, retraining, and redeployment are all made easier using these tools. But this brings us to a question that who exactly machine learning is for? So individuals and teams deploying MLOps inside their company can use Azure Machine Learning to move machine learning models into production in a safe and auditable environment. Data scientists and machine learning experts will find tools to help them speed up and automate their daily tasks. Tools for embedding models into applications or services will be available to application developers. Platform developers will find a strong set of tools for constructing advanced ML technology underpinned by resilient Azure Resource Manager APIs. Now that we know the basics of Azure ML, let's have a look at its infrastructure, readiness, and security. So Azure Machine Learning is an Azure cloud platform that adds security to machine learning projects. So integrations for security include the following: network security groups in Azure Virtual Networks. Azure Key Vault is a vault where you may store security secrets like storage account access details, and set up an Azure Container Registry behind a VNet. So now let's dive down deep and explore its project workflow. Models are usually created as a part of a project with a specific goal and objective. Multiple people are usually involved in these projects. Iterative development is used while experimenting with data, algorithms, and models. Now coming to the project life cycle, while the project lifespan will differ depending on the project, it will typically look like this. A workspace organizes a project and facilitates collaboration among multiple users who are all working toward the same goal. Users in a workspace may easily share the result of their experiments through the Studio user interface, or they can use versioned assets for jobs like environments and storage references. So users' work can be automated in a machine learning pipeline and activated on a timetable or HTTPs request when a project is ready for operation. Therefore, models can be deployed to the managed inferencing solution in real time or batch, abstracting away the infrastructure management that is traditionally necessary for model deployment. Now let's proceed further and understand the concept of MLOps, that is DevOps for machine learning. MLOps or DevOps for machine learning is a process for generating models for production use. If not reproducible, the lifetime of a model from training to deployment must be auditable. MLOps or machine learning operations is based on DevOps principles and methods to improve workflow efficiency. Continuous integration, delivery, and deployment, for example. These ideas are applied to the machine learning process by MLOps with the purpose of experimentation and model deployment can be done more quickly and quality assurance and end-to-end lineage tracking are more efficient ways to put models into production. Now, let's explore what is Azure ML Studio. So, Azure Machine Learning Studio is an online service that includes low-code and no-code alternatives for project development and asset management in Azure Machine Learning. Basically, it is a workspace where you can create, build, train the machine learning models. For an inclusive data science platform, the studio integrates no-code and code-first experience. So now that we have covered all the important concepts of Azure Machine Learning, let's have a demo for a better understanding of how machine learning is used in Azure. So let's start with a demo. First, you need to browse the link studio.azureml.net, and here you need to log in with your Azure account. So once you have logged in, you will be led to a new window. This is the new window. Here you can see a few options. So let's start and see one by one what these options are. So the first one is projects. Basically, this gives you a list of all the experiments that you have already worked on. So here you can see we haven't worked on any experiment yet. Then comes experiment. Experiments are all the programs and codes that you have worked on to create it or deploy a model that you have just created for an experiment. So as I said, we haven't created any experiment yet, so the list is null over here. When you click on samples, you can see a few sample experiments provided to you by Azure portal by default. And following that, we have web services. So we all know, since Azure is a cloud computing platform, so all the data gathered from our experiments needs to be uploaded to the cloud. So web services gives you a list of all the experiments that you have in the cloud, so you can access them from anywhere. So when you create an experiment and work on it, when you add it to the cloud, that data is stored here. So then comes data sets. It gives you all the data sets you have in your Azure portal. When you click on the samples option, again you can see all the data sets provided to you by default in your Azure portal. Then comes train models. So while working on an experiment, you will come across a point where you need to train your model. So basically, this gives you a list of all the models that you have trained in your experiments or Azure programs. And in the last comes settings. Any changes that you want to make to your workspace is done under settings. Here you can see this is your workspace name, workspace description, which is by default, and all the details is provided here only. So whatever changes you want to make to your workspace, you will be doing this over here. So now let's start with a demo. So down below you can see the add or new option here. So click on it, and then you can see there are a few templates provided to you by Azure itself. So we'll click on blank experiment. Once you click on the blank experiments, you'll be guided to a new experiment window. So this is the new window, and this window is divided into three parts. These are the components where you will plan your model. This is the canvas to design your model, and then the properties of the model. In the components section, you can see samples already present there. So you can select any one of them according to your requirement. So here, when I'm typing samples, I'll work on airport codes datasets. So I just need to drag this option over here. But before starting with our experiment, let's change the name. So here I'm changing it to airport codes demo model. So now you can see the name of the experiment is changed. Now when you click on it and select visualize, just a second, you can see the number of rows and columns provided to it, the data which is required for its dataset to be created and for its model to be created. So the 4 rows, 4 columns are airport ID, city, state and name. Now we will move towards the part where we define the field we need to make our predictions for. So type columns in the search bar. Under manipulation section, you can see there are multiple options provided to you. So here we will select columns and data sets, as we are working on data sets. Now connect your data set with this option. So you can see a red alert over here. So when you click on it, you can see it is asking for values in your data set. So to add values, click on the launch column selector under properties section. So once you click on it, here you need to select all the options needed for your required values. So for my experiment model, I need all these data sets. So I'll add all of these and then click on the save option. So let me just add these. So now I have saved all the values I need in my data set. So now you can see the alert is gone. So now we have the data sets that we want to work on. So let's look for an appropriate algorithm for it. So while looking into the classification algorithm, we know that our so here you can see it under classification model, we have these options. So we know that our target value is divided into 2 classifications. So the algorithm we will be using is a 2 class. So we will be using 2 class booster decision tree because it calculates the accuracy for every node, and once the calculated accuracy is more than our required accuracy, then only it moves to the next node. So basically this gives you a prediction value close to the accurate value of the model. So we will just drag this option over here. So now the next step we have is to train our model. So we just need to type train over here and select train model option. So just drag it to the canvas. Now connect the 2 booster decision tree to the train model. Now you can again see the red alert for required data, as it doesn't have any data to work on. So our next step is to split the data. So we'll type split and drag the split data option on our canvas. As you can see, this is also saying it needs an input port data set. So we'll connect our data set with it so that it is provided with the data. So when you click on it, you can see it is asking for a split percentage. So you split the data into training and testing, where 80% goes to training and 20% to testing. So we will mention 0.08 over here, and so now we will just connect the 80% data to the train model. As we said, the 80% goes for training. But you can still see the alert in the train model because it is not aware of the column it needs to train on. So we will click on launch column selector. Now you just need to select all the columns you need to work on. So I'm selecting the airport ID number. Now you can see once I save it that the alert is gone. Now our next step is to find the score of our model. So let's type score in our search bar and drag the score model over here. Let me just reduce the size of the canvas. Yeah. So we will just connect our train model to the score model. So again you will see the red alert as it doesn't know the data it needs to test on. So for that we will connect the remaining testing data in the split data option to the score model. Now you can see the alert option is gone. Now coming to the final step, that is evaluation of the model. So let's type evaluation, and here you can see the evaluate model option. We just need to drag it to the canvas. Yeah. So let's connect it with our score model. Now your model for the airport code dataset is complete. So this is the whole model. Now you need to save the model and then click on run option. So here I have saved it, and you can see it's running. You can see the model running and going through every node. As you can see the green mark as it's verifying through every node. So once it's done, click on evaluate model and then click on visualize. Now you can see the accuracy is 98. Here you can see the accuracy is 98, which is almost the prediction value. Now you can see the positive and negative labels as well. So this whole data is known as confusion matrix. Now for the values close to the positive label, it gives me the number of true predictions. That the number of data I'll provide, it shows that 72 predictions will be right and 1 will be wrong. Now let's go back and run this model over the web. So by clicking on setup web service, we will click on predictive web service. Now we will just connect web service input to the score model. So that once the program is uploaded to the cloud, it is directly connected to the score model and gives us the output. So now you need to save this and run. This will execute the entire model. Now all we are left with is deploying the model. Now we just need to click on deploy web service. So then you will see you will be taken to a new window. Here you can see the response page where it's showing the test option. You need to click on it. So here you can see a new window has popped up. So you just need to mention the details. Like for city I am mentioning Bangalore. For state I am mentioning Karnataka. And name of the airport is Kempegowda International Airport. And I just need to save this data. So now down below you can see it gives me predictive values, and this is the airport ID for my mentioned details. So the accuracy of this ID will be 0.98, which is 98%, which is almost accurate to the 100%. So this was our experiment, and this is how we can use ML in Azure.